Okay, let's walk through these questions for your 9192 quiz review. All right. So feel free to skip ahead in the video if you just want to try and find a certain question. I'm just going to go through all of them one by one. So here we go. Number one, find the amount of interest earned on an investment of $7,500 earning 4% interest per year compounded annually for 1 year. Now on this problem, there's more than one way you can do it. So if you get the right answer, but you did it with the PRT formula, that's fine. But just to be consistent with this and number two, I'm going to use my compound interest formula. So my compound interest formula is A equals P, then 1 plus, let me move my microphone, hold on, so I can write better. 1 plus K to the N power. So we are starting with a $7,500 investment. So A equals $7,500 investment. 1 plus K. K is 4% per year, compounded annually. So that is going to be the straight up 0.04. And then for 1 year, so it's only going to be compounded once. So N is 1. And what that comes out to as a final amount, that comes out to, well, let's type it in our calculator, right? 7,500, 1 plus 0.04 to the first power. Oops. And we get 7,800. So the answer is not 7,800. The answer is how much interest did I earn, right? How much interest did I earn? $7,500 accumulated into $7,800. So I gained $300. And that $300 that I gained was the interest that was paid. I still had $7,500 of the original amount, but I got $300 just from interest. So that's how much interest gained me. So be aware of the answer to that question. The fact that you are finding out what the difference between those numbers are, what you gained compared to what you started with. So number two is pretty much the same thing. Find the amount of interest earned. So we're going to take our $120,000 and we're going to see how much money gets earned from that and see how much it grows. So this is going to be 6% per year, but it's compounded quarterly. So the K value is the 6%, which is 0.06, divided by 4 since it's compounded quarterly. And 0.06 divided by 4 is 0.015. So it's going to be 0.015. It's the K value. And then N. So it's compounded quarterly, so that's 4 times a year for 4 years. So 4 times a year for 4 years will be 16 times in total. So let's type this in the calculator, 12, 0, 0, 0, 0, 0, whatever. One more 0. 1 plus 0.0125, or no, oops, did that wrong. 0.15, close the parenthesis, to the 16th power. Oops. And we get $152,278.27 if you round up. So we started with $120,000 and we ended up with $152,278.27. So how much money did I gain? That's the amount of interest that I earned. Again, pay attention to the question. Okay, the question's asking how much interest did you earn, not what do you have at the end of the 4 years. It's how much did you gain over those 4 years, basically. So take that value we just got as our answer, subtract the amount you started with, and this should tell us how much we gained. So we gained $32,278.27. So that is our answer, number 2. Number 3, Nerf Sebastian has an opportunity to buy vacant land near the outskirts of town for $90,000. He feels certain that he can resell the land within 5 years for $125,000. The Fourth Federal Bank of Metroburg is willing to lend him $90,000 for 5 years at an annual interest rate of 7%, compounded yearly, with principal and interest due in 5 years. If he borrows the money and holds the land for the full 5 years and then sells it for $125,000, will he make profit or incur a loss? So what we need to do is, okay, well, let's understand the problem. We are taking a loan out for $90,000 from our bank. Now that loan is going to accumulate interest. I'm going to have to pay that $90,000 back plus interest. So what I need to do is find out how much money I'm going to pay back the bank. How much am I going to owe the bank in 5 years? I'm obviously going to owe them $90,000 plus that interest, but what will that interest accumulate to? So that's the first question. I need to figure out what that loan amount, that $90,000 loan, will acquire or accumulate to in 5 years. So it's 90,000 is what we started with. It's 1 plus, and we're growing at a rate of 7% compounded yearly. So it's just going to be 0.07. It's not quarterly, so I'm not dividing it by 4 or anything like that. It's compounded 7% yearly. So just plain old 0.07. And now N, if it's compounded yearly, it's once a year for 5 years. So it's just going to be to the 5th power. So let's calculate this. We have $90,000 plus, I got to do the 1 parentheses, 1 plus 0.07 to the 15th power. I was going to say 16, but that was the last problem, I think. 5, so the 5th power. So that comes out to be $126,229.66. So now let's look at the question. I bought the land. I borrowed this money to buy the land, and I'm going to sell it for $125,000. Now I owe the bank $126,000. So I'm not making any money. In fact, I'm losing money because I got to pay the $125,000. I mean, I made the $125,000, but I have to pay the bank $126,000. Well, then I'm not really keeping any money for myself. In fact, I have to spend some of my other cash to end up paying the bank back. So it's a loss because we owe the bank more than we're going to make from selling a property. It's a loss. And if we take the difference between the amount we owe the bank and the amount we sold the property for, it's a loss of $1,229.66. So, interesting. What is the maximum annual interest rate he can pay and still make a profit of $10,000? So, remember, we're selling the land for $125,000. So if we sell it for, and some of that money, some of that $125,000 will have to go to the bank, if not all of it. But if we're going to sell it for $125,000 and keep $10,000 of it in profit, then I can't owe the bank any more than $115,000, right? If I owe the bank $115,000 and then I keep $10,000 to myself, 200, there you go. Right, then that totals up. That's my $125 profit split up, or my $125,000 sale broken up. I sell the land for $125,000. I keep $10,000 of it for profit, and then I pay the bank back the $115,000. So the question is, what annual interest rate will allow me to keep a $10,000 profit? So go back to this formula, right? A is a very important number here. A is our amount that we owe the bank. And in this case, A ended up equaling $126,000. But for my hypothetical problem here, I want to pay the bank no more. I don't want to be indebted to them any more than $115,000. So that's the max total that I would have to owe the bank. So that's technically the A value for this problem. Now, I still started with a $90,000 loan. That's not going to change. So that's still going to be that original amount. We have 1 plus K. Now, the idea is we're looking for what value of K will work for this scenario. So I'm trying to solve for that. And it's still over the same 5-year period, so N is still 5. So the trick to this problem is setting it up right. Setting it up so that you have the $115,000 over here as your A value. So we have $90,000 loan. It will accumulate at some interest rate for 5 years and grow into a $115,000 loan. But of course, we need to figure out what that interest rate will be. So if we treat this like a regular algebra problem and solve for K, then we're going to have to divide this 90,000 from both sides. So if we take 115,000, divide it by 90,000, we're going to get 1.2777. I'll go ahead and just write that in as 1.278 because the 777 will round up to just 8. equals the 1 plus k to the 5th power. Now I need to get rid of the power of 5, the exponent of 5. So to get rid of the power of 5, I will take the 5th root of that side. So if I do it to the right side, I have to do it to the left side. So that's just going to cancel out the exponent on the right, just leave you with 1 plus k. And on the left, I need to take the 5th root of that number. Now for me, because I don't want to mess up my rounding, how I'm going to type this in the calculator, you see how my answer, the last answer I already got was a 1.27777? I'm going to actually use that directly in my next calculation. So I'm going to hit the math button, and I'm going to select my root here, and I'm going to choose 5th root. And I need to take the 5th root of that last answer. So if I hit second and then the negative sign at the bottom, it will insert that last answer I just got. So it's doing the 5th root of the 1.2777. And I'm doing this because I don't want to have to mess with rounding. I want this answer to be as accurate as possible. And so I get 1.0502 if we, again, put it on paper, rounding it a little bit. So if you subtract the 1 from both sides, then k ultimately ends up being the 0.0502. So that's our k value. Now, as a percentage, you move the decimal back over there, and as a percent, that means 5.02%. You can say 5% if you want to. That's probably more normal, but I want to be as accurate or specific as possible, but 5% would work. If you said 5%, that's fine. All right, now I took up too much space there, so I got to erase this. You guys have the rewind feature and the pause button, so if you really care to see that more, then crap. Then you can just go back and see it. Number 5. Number 5 is very similar to the problem we just did in terms of how we set it up. So an investor purchased a classic car in 1995 for $40,000 and sold it in 2015. He had a net profit of $70,000. What is the effective annual yield on his investment of $40,000? So here's what's happening. He buys a car for $40,000. If he were to sell it for $40,000, then he would make no profit, right? He bought it for $40,000, sold it for $40,000, so he didn't really make any money on the car. But this tells us he bought it for $40,000, he sold it and made a profit of $70,000. He did not sell the car for $70,000. He made $70,000 off of the car. So the question is, what did he sell the car for? If he bought it for $40,000 and earned a $70,000 profit, what did he sell it for? Well, if you add those two values up, $40,000 plus the $70,000, that would be a total of $110,000. So what's happened is he bought the car for $40,000, sold it for $110,000, and that difference of what he gained $70,000. That's his profit. That's what the problem said. So getting that $110,000 is very vital for this because that's what the car is worth in 2015. At the end of the period, the car is worth $110,000. But again, we're setting it up very similar to this. At the beginning of the period, it was worth $40,000, right? So that's your P value. That's your, if you're using this formula, A equals P 1 plus K to the N. A is the amount at the end of the term, which is the 110,000. P is the value at the beginning, which is the 40,000. And annual yield, we're looking for the rate. We're looking for the interest rate, just like we were doing in the last problem. Now, the n exponent here is 20, because 1995 to 2015, that was 20 years. So the car was bought for $40,000. 20 years went by, and he sold it for $110,000. So what is the interest rate that it grows? So just solve this the same way you solved the last problem. Divide both sides by 40,000. Right, 110,000 divided by 40,000 equals that. Then you'll have to take the 20th root, right? You'll have to get rid of the exponent, so you'll have to take the 20th root of that. So we'll take, just kind of rushing it here because it's pretty much the same as the last one. So if you don't know what I'm doing here, then you didn't know what we did on the last problem, and that's just That sucks. All right. 20th root of that answer, that's the 2.75. I'm going to just hit that. I know I could just type it in, but 20th root of that answer is 1.0518. Again, so then you have that equal to 1 plus k, so you subtract the 1, and you get the k value is equal to 0.0518, which as a percent, if you move the decimal back over, it's 5.1. Well, if you round the 8 up, because it is 8, right, you would have 5.19%. So you could probably say 5.2%. That's fine if you round it even further up, but you get the general idea. Number 6. Find the present value of $50,000 payable in 7 years if the interest rate is 6% per year compounded quarterly. So our present value, now keep in mind, you're going to have two present value formulas. You have the present value of an annuity, and then you also have your basic present value formula. This is just a basic present value formula. This is not an annuity. To know the difference, an annuity is something where you're paying like per month or per week or something. You're continuously making payments into an account over time, whereas this problem, we're not making any payments into any account. It's just, $50,000 what we owe in 7 years. What's it worth now? It's not talking about any kind of payments every year, every quarter, or something like that. So when it talks about payments, it's an annuity. So our present value formula is A equals, or actually it's P equals, right? P equals A over 1 plus K to the n power. So A is our final amount. So the amount payable in 7 years, or our final amount, is the $50,000 divided by the 1 plus K. So K is the 6%, but it's compounded quarterly. So 0.06 divided by 4 makes our K value. So 0.06 divided by 4, makes the K value 0.015, so plus 0.015 to the n power. So it's 7 years compounded 4 times a year. So 4 times a year for 7 years means it's compounded 28 times. So that is our formula. Now we just got to plug it in the calculator. So to type in this fraction, I'm going to hit alpha y equals, and then choose that number 1 option, just hitting enter, and typing this fraction. So 50,000 on top. And then on bottom, we have parentheses 1 plus 0.015 to the 28th power. And I get 32,954.96 as the present value. So basically, I'm going to owe $50,000 in 7 years, but today that loan is worth $32,954. All right. Don't check your phone while making a video. It's fine. All right, number 7. Adam has a choice of 2 alternatives to raise some cash. In the first, he must repay $10,000, including both principal and interest, at a rate of 8% per year compounded quarterly after 1 year. In the second, he must repay $12,500, including both principal and interest, at a rate of 12% per year compounded quarterly after 2 years. In which case will he receive more cash in the beginning of the loan period? So again, it's asking about the amount in the beginning, which is our present value. It's not an annuity because there is nothing here that talks about any sort of payments into the account every quarter or something like that, or every month. It's just a regular present value formula, so just the same thing we were just doing on the last problem. The A over, or actually, I'm sorry, yeah, it's the P equals A over 1 plus K to the n power. We have to do that twice. We have to find the present value of the first loan, and then we'll find the present value of the second loan, and we'll see which one will have the bigger present value, essentially. So the first loan is $10,000, and it's compounded 8% per year, compounded quarterly. So that K value for that would be 0.08 divided by 4, since quarterly is 4. So 0.08 divided by 4 makes 0.02. And then the N. So it's quarterly, so it's 4 times a year, and it's for 1 year. So that means just 4 times in total. And that number will come to, if we type it in, $9,238.45. All right, so now I need to find the present value of the other loan. The other loan is $12,500 payable at 1 plus the interest rate here is 12% compounded quarterly. So that'll be 0.12 divided by 4, which makes 0.03. And then if it's quarterly, that's 4 times a year. For 2 years, that's 8 times in total. So we'll type this in, and we'll see what it gets us. So and that comes out to be $9,867.62. So which one has a bigger present value? Well, the second loan has a bigger present value at $9,867.62. All right, number 8. Number 8 is find the amount of an annuity. Okay, so $500 paid quarterly for 10 years at 5% per year interest. So our annuity formula is S equals Y over K, and then it's 1 plus K to the N power minus 1. So we're just going to plug all those values into that formula. And if you don't mind me checking for a second, I just want to make sure I did not mess that up. I want to make sure I'm using the right formula. I know I'm pretty sure I'm close, but I don't want to be wrong. So that's my chair squeaking. It's all good. Yeah, we're rolling with it. All right. Put that on the ground. Okay. So Y is our monthly payment or quarterly payment. It's whatever we're paying after a certain period of time. So we're paying $500 quarterly. So that $500 is our Y value. So that'll be $500. And then K is 5%, but it's compounded quarterly. So 0.05 divided by 4. Our K value is going to be 0.0125. And then we have 1 plus K, again, same number, 0.0125. To the N power, so it's quarterly, 4 times a year for 10 years. So 4 times a year for 10 years will be 40 times in total. And so there we go. Now we just need to type this into our calculator. So alpha Y equals, just to get me my fraction tool, so I have 500 on top. Then I'll have 0.0125 on the bottom. I'm going to open 2 sets of parentheses. And this set will have 1 plus 0.0125. Close that, raise that to the 40th power. And then subtract 1 and close that. And we should have what looks like we have on our paper. So hit enter and we get $25,744.78 as the answer for that problem. All right, it's very simple. I mean, it's just plugging in numbers into a formula and typing in the calculator. Just make sure you use the right formula. That's all. Number 9, find the present value of an annuity which pays $20 per week for 90 weeks with an interest rate of 0.1% per week. So present value of an annuity, it's a different formula. That formula is V equals Y over K. And then it's 1 minus 1 over 1 plus K to the N power. I think it's just that. Yep. So present value of an annuity. It says it right there. That's how I knew which formula it was. Let's plug everything in. Again, Y, just like in the last problem, Y is going to be our deposit per period of time. So like $500 quarterly, but in this case, it's $20 a week. So that's $20. The K value, don't be fooled by this. This is tricky. It's 0.1%, but you can't put 0.1 because you didn't change it from a percent to like a numeric decimal. So 0.1% still follows the same rule of moving the decimal place to left. So if you move it 2 places left, it becomes 0.001. So we have to be very careful about that. So it's 0.001. Then we have 1 minus, we already know 1 plus K, again, K is 0.001 to the n power. So it's 90 weeks, right? This is everything's talked about per week. So total of 90 weeks. That should be everything. And let's type this in our calculator. So alpha y equals, we're going to type in 20 over 0.001, open parentheses, have 1 minus, open parenthesis again, go back to alpha y equals because I got to type in another fraction. So it'd be 1 on top and then 1 plus 0.001 on the bottom. Make sure I get out of that and close that parenthesis. And then raise that to the 90th power. Oops, to the 90th power. Get out of that and then close that parenthesis. So it's a bit messy, but it's there. And we get an answer that is $1,720.55. All right, now we're almost done. 2 more problems. So Jennifer makes a down payment of $2,500 on a new car. She then agrees to pay the balance of the car's price plus interest by paying $175 per month for 48 months. If interest is charged at a rate of 6% per year and there are no other charges added to the price of the car, what is the cash price for the car? All right, so basically, it's an annuity because we're paying a certain amount every month. So when you talk about payments, again, you know you're dealing with an annuity, and our annuity formula is S equals Y over K, 1 plus K to the n power minus 1. So if we plug in everything we know the Y value, our monthly payment amount is $175. Now K is 6% per year, but because we're talking about monthly payments and everything's done by month, I need that 6% to be a monthly interest rate, not the yearly interest rate. So we take the 6%, we divide it by 12, and we get the monthly interest rate, which is 0.005. So then we have 1 plus that 0.005. The n power, it's 48 months. It's very straightforward. Then minus 1, and we're good to go. So typing this all in, alpha y equals, got the 175 on top, 0.005 on the bottom, 1 plus 0.005. All right. So there we go. I believe, let me just double check, make sure I typed that in right. I think it is. Hit enter, and the value, now pay attention real quick. Listen to this. So the annuity amount is $9,467.12. But we paid $2,500 up front for the car. So if we add that $2,500 we paid up front, so this is the amount we're paying back on the loan, and this is how much we paid in the beginning. So if we total up how much we're paying, we actually buy the car at $11,000 or $11,967.12. So that's the actual value of that car. All right, and then one more question. So the last one, there are 2 debts that we owe. We owe $6,000 in 4 years, and we owe $5,000 in 6 years. All right, but we want to consolidate these loans into just one loan. Instead of owing 2 different bills, we'll just have one bill. We'll put them together. So now to do this, what we need to know, because these are the future values. This is the value of the loan in 4 years, and this is the value of the loan in 6 years. But I want to know what today's value of the loan is. I want to know how much these are worth right now. So I want to find the present value of both of these. Now this goes back to earlier, we talked about our present value formula, the A over 1 plus K to the N. This is just a regular present value. This is not an annuity because remember, annuity has to do with certain payments over certain times. There's no payments here. It's just here's what the loan's worth in the future. What is it worth today? So it's just a regular present value. So if we find the present value of both of these, we'll start with the $6,000 one. $6,000 loan's present value will be K. Let's see, what's K? So it's 7% compounded semi-annually. So that's the 0.07. Semi-annually means twice a year. So divided by 2, K is 0.035. Now, N, this is for 4 years. If it's compounded twice a year for 4 years, then it's compounded 8 times in total. So that amount gets us 6,000 divided by 1 plus 0.035 to the 8th power. That amount gets us $4,556.47. Now I'm putting that number over there because I'm going to run out of space. I want to make sure I keep everything together. So the next present value is going to be for the $5,000 loan. So the $5,000 loan, its present value, it's the same 7% semi-annually, so it's still going to be 0.035. But this one's for 6 years. So 6 years, twice a year, will be 12 times in total. So alpha y equals, get that, we'll type it in 6,000. Then 1 plus 0.035 to the 12th power. And the value of that loan is 3970.7. Wait, that doesn't seem right. Did I do that right? Oh, it's 5,000. I hit 6,000. Yeah, okay. I was going to say something seemed wrong. Let me do that one more time. You probably were like screaming at me, right? 5,000. There we go. I was going to say, this doesn't remind me of the answer I got earlier. $3,308.92. So this is the present value of the loans today. So this is what the loans are worth right now. So if you put them together, you add those two loans, then what they're both worth right now is $7,865.39. That's how much they're worth right now. Together, my loans are worth $7,865.39. Now, what I'm going to do, because I still need to figure out what am I going to owe after 5 years if I consolidate them. So if that's the present value of my loans, that's what they're worth now, $7,865.39. Right? Note the formula that I'm going to use, my regular compound interest. I know what my loans are worth right now. I want to know what they're going to be worth in 5 years. So take my present value, multiply it with the 1 plus K. K is the same as the thing before. It's still 7% compounded semi-annually, so still 0.35 or 0.035. N, if it's for 5 years, done twice a year, then N is 10. So this will tell us what our loan amount is worth in 5 years at that 7% compounded semi-annually. So 7,865.39 times the 1 plus 0.035 to the 10th power, and that gets us an $11,094.91. All right, that's going to cover it. I know I kind of speed run that, but I'm trying to do this as fast as I can. So it's better than nothing, I figure. So let me know if you guys have questions on Remind or something, okay? Or come see me during Lion time or whatever. But good luck on your quiz. All right, I'll see you tomorrow.